So the concept of proportionality is basically just a fancy term to say unit rate. And when two quantities are directly proportional, so they have a proportional relationship, they can be represented by y equals kx. So y is one quantity and x is the other, and that the way that they're proportional is some number times x will give you y. And so basically it's the relationship between two quantities where one quantity is a constant multiple of the other. So if I had x is 1, and the only way that I would be able to figure out y is by multiplying 1 by the constant of proportionality known as k. If x is 2, the only way that I can figure out y is by multiplying it by that same constant of proportionality. Constant of proportionalities will change based on relationships. But when one quantity changes, the other quantity changes by a constant factor known as the constant of proportionality, which is represented by the letter k. So only proportional relationships have a constant of proportionality, which is just basically a consistent unit rate between the input and the output. So if I looked at the data table, which looks like it's the representation of side lengths and the relationship between side lengths and the perimeter in inches. So the way that I would think about this is that would be my x, and this would be my y. So x would be my input, the numbers that I put in, and y would be my output. So x, in order to figure out y, I need to know x. So if I were trying to figure out if this represented a proportional relationship, I would create ratios of y over x. And it's always, always, always going to be the output over the input. So in this case, if I were to compare, my question would be, does 8 over 1 equal 16 over 2 equal 24 over 3 equal 32 over 4? So I'm taking the numbers that are what I consider my outputs or my y's to get my x's. Sorry. The output of my y's over the input of my x's to get what I'm going to call my unit rate, also known as my constant of proportionality. And the reason I know that my side lengths is the input and my perimeter is the output is because I can't figure out my perimeter unless I know my side lengths. So in this case, it appears that because 8 over 1 is the same as 16 over 2, is the same as 24 over 3, is the same as 32 over 4, so they are all equal, that it does represent a proportional relationship. If I look at reducing all of them, I would get a constant unit rate of 8 over 1. Okay, so my k in this case, my constant of proportionality, is going to be 8 or 8 over 1. So if I'm asked to write an equation to represent the data in this chart, based on what I know from the previous slide, my equations are always going to be the output equals the constant of proportionality times the input. So in that case, because we just found out that k is 8, my equation would be y equals 8x. And what this equation will let me do is figure out any output given an input for this particular relationship. So in this particular relationship, we know that the output y is 8 times the input x. So in this particular case, again, we know that the perimeter will always be 8 times the side length. So if I wanted to figure out the question mark, which is what the perimeter is when side length is 9, I could say y equals the constant of proportionality times 9, right? And I should end up getting 72. And what that tells me is since the output is 8 times the input, the perimeter should be 8 times the side length. So we're looking at the data table. It's a very traditional looking data table. We have the x values or the inputs as the first row and the y values or the outputs as the second row. If we're trying to figure out if this chart represents a proportional relationship, we're going to go ahead and figure out if the relationship between the outputs and the inputs is consistent or the same. In other words, if they reduce to the same unit rate. So I'm first going to put 0 over 0 and realize that doesn't work. The good news is it doesn't have to, because we can't divide by 0. It gives us an error. 0, 0 is a very important point that we'll touch on in a second. So we're going to go to the next relationships. So we're going to put 10 over 1, 20 over 2, 30 over 3, and 40 over 4. So we're putting the outputs of number of gallons over the inputs of number of minutes. We're reducing all of those, or we're seeing if they're equal, and to see if they're equal, most of the time we have to reduce them. And we notice that they all reduce to 10 over 1, or 10, which means to us that our constant of proportionality, or our K, is going to be 10 or 10 over 1. Good news is it does represent a proportional relationship, which means we will be able to create an equation that will recognize this proportional relationship. If I were to write this proportional relationship as an equation, its output equals constant of proportionality times input, and in this case the constant of proportionality is 10. So their equation is y equals 10x, which means no matter what the number of minutes, the number of gallons used will always be 10 times the number of minutes. So if I happen to want to know in 50 minutes how many gallons I'm going to use, I would multiply 50 by 10 and recognize that I would use 500 gallons. I also mentioned that 0, 0 is an incredibly important point. The reason this is an important point is because every proportional relationship has a point or a data set that has a relationship of 0, 0. No proportional relationship can have an input of 0 without also having an output of 0. Because if you think about, and we'll just use this example of y equals 10x, if you think about a proportional relationship as simply being the output equals the constant of proportionality times the input, if my input is 0, if I put 0 in for x and all I do is multiply 0 by 10 or 20 or 50 or 100 or any other constant of proportionality, no matter what I'm multiplying 0 by, what constant of proportionality I'm multiplying 0 by, my y value should also be 0. And if my y value isn't 0 when my x value is 0, I cannot have a proportional relationship. So if I were to see if this data table represented a proportional relationship, I would go ahead and recognize that I would want to see my relationship of y over x to see if they're the same. 2 over 0, well again we're dividing by 0, so we won't use that. If we compare 4 over 1 to 6 over 2 to 8 over 3 to 10 over 4, what you're going to notice is they're completely different ratios. 4 over 1 reduces to 4, 6 over 2 reduces to 3, 8 over 3 reduces to 2 2/3, and 10 over 4 reduces to 2 1/2. So none of these unit rates, none of these reduced fractions are equivalent. So this relationship does not represent a proportional relationship. The other thing I just want to point out is that 0, 0 is not part of this data table. And like I said in the last slide, if 0, 0 is not part of your data table, then the relationship cannot be proportional. But if you look at the relationship between the comparisons between the y's and the x's, they're not the same multiple. 1 times 4 is 4, 2 times 3 is 6, 3 times 2 1/3 is 8, 4 times 2 1/2 is 10. So you're not multiplying the input by the same number to get the output. If you're asked to identify an equation that represents a proportional relationship, your goal is to look for equations that just have a similar look to y equals kx. So the only thing you're looking for is that your input is being multiplied by a number, and that's all that's happening in the equation. So when you look at something like y equals 4x, no matter what your input is, the only thing that you're doing to that input is multiplying it by a common 4 every single time. So if we were to pick random inputs, and you can choose any 3 you want, my favorite are 1, 0, 1, and 2. When I pick that input and I plug in my input every time, the only thing that I'm doing to that input to get my output is multiplying it by 4. So 0 times 4 will give me 0, and 4 times 1 will give me 4, and 2 times 4 will give me 8. So the only thing I'm doing with that input is multiplying it by 4, and by multiplying it simply by 4, what I'm creating is a relationship where the y value is 4 times the x value, which will give us equal ratios, because 4 over 1 is the same as 8 over 2. They both reduce to the same unit rate of 4 over 1, which results in the same constant of proportionality of 4. So y equals 4x does in fact represent a proportional relationship, because the only thing we're doing is multiplying every input by the number 4, the constant of proportionality. If we were to look at the next equation, which was y equals 3x plus 2, in this situation, every time you have an input, you're multiplying it by 3, but then you're adding 2. So it's not just a multiplication situation anymore. So when you do pick inputs, if I were to plug 0 in for x in this situation, not only would I be multiplying 0 by 3, I would also be adding 2. So my output in that case would be 2. And if I did the same thing for 1, okay, when I multiplied 1 by 3, I got 3, but then I had to add 2, so I got 5. And then if I plug 2 in, 3 times 2 is 6, plus 2 is 8. So in this case, when I compare my relationships of y over x, I get 5 over 1 and 8 over 2, and 5 over 1 is a unit rate of 5, and 8 over 2 is a unit rate of 4, and so there isn't a constant of proportionality. There is no equivalent unit rates involved. So in this case, y equals 3x plus 2 does not represent a proportional relationship, because it's not just a multiplication problem. There is an additional addition in that problem. If I look at y equals 0.25x, basically this is saying I'm taking my input, I'm multiplying it by a quarter, and I'm getting my output. All I'm doing is multiplication. So yes, it does represent a proportional relationship, and I can identify the constant of proportionality as 0.25 or 1/4. And y equals 0.75x minus 1.50 does not represent a proportional relationship, because it's not just simply a multiplication problem. Anytime you add or subtract something, you're ruining the proportional relationship, because it's no longer going to result in equivalent unit rates.